Subsurface AI, accelerating subsurface workflows for E&P industries. We are Subsurface AI, formed originally in 1996 as Geomodeling Technology Corp., headquartered out of Calgary, Alberta, Canada. The past 6 years, we've been working on AI algorithms and machine and deep learning algorithms. We formally rebranded as Subsurface AI in 2023. We will be focusing on interpretation AI, unconventional AI, integration AI, and geomodeling AI.
The subsurface AI workflow crosses all aspects of interpretation, from well interpretation all the way through to static reservoir modeling. You use your regular interpretation techniques, but they are significantly enhanced by AI. The AI allows you to increase your productivity by 10 to 100 times. We also have the capability of introducing engineering data into your regular workflow. This is done by reading in the engineer's spreadsheet. Then you can turn the engineer's data into logs that you could use just like other logs, make predictions on, use for predictions. The ultimate goal of all this is to build a static reservoir model. You can see the arrows starting at well top picking and going to the static reservoir model. But our workflow allows you to go the other direction as well in order to enhance the interpretation of earlier parts using information that you gained from, say, geology or engineering. I'm now going to show you the interpretation AI package, which is part of Subsurface AI. We've packaged our software into different components in order so that you can just buy the components that you need to do your particular job. In this particular case, we're going to be using interpretation AI to interpret faults. It also has the capability to interpret geobodies, sequences, which are related to the horizons, but a better way of doing it, facies, and reservoir properties. You're going to be able to do this quickly. So you're going to do your normal interpretation. One advantage of our software is that you can turn a prediction on a particular line into new training and then edit that training. This significantly improves your ability to quickly interpret faults because the AI is doing most of the fault interpretation for you. Here you can see that happening. So the interpretation is in red. The predictions are in black. You do a little bit, and now you're going to check your interpretation just as you normally would by looking at it in section, by looking at it in 3D, scrolling through your cube, looking at the faults themselves to make sure that they make sense. And you can always go back and turn the AI into an interpretation and modify it in a particular area, retrain, in order to get your faults, or whatever it is you're interpreting, exactly right. Here we're going to use interpretation AI to train a salt dome. Now in this particular case, just like any other geobody, you're going to draw a sketch around that geobody. Other geobodies that we can do are channels, reefs, and general geobodies. For the salt dome, you're going to do some training. And then the way I like to use it is to move to another line, make a prediction, and then turn that prediction into new training. This is, again, one of the big advantages of interpretation AI and speeds up things substantially. That new training can then be edited by either resketching the entire thing, erasing bits, or using any of the other editing tools. Once you've trained it, then you can move along to another line, and all the previous training is used to make the new prediction. You keep doing this until you're happy with the predictions that you're seeing on the various lines. And then you're going to work your way through the body and ensure that everything makes sense throughout your volume. You can also want to interpret and review it in 3D. And so we have the capability of doing that. One of the unique things about subsurface AI is our ability to incorporate engineering data into our analysis. You can read in anything that's in an engineer's spreadsheet: production, completion information, pressures, microseismic events. If those numbers are associated with a location down the wellbore, then we can treat them as logs. Just as we deal with any other log, we can do things like make predictions. In this particular case, we're going to make predictions of production using our tool Integration AI, which incorporates all the various disciplines from geology through petrophysics, geophysics to engineering. And because this is a shale play, unconventional AI. Now what you're looking at here is in the background a prediction of production, where zones of higher production are indicated by the reds. The wells are colored in the same color as the production. And what you can see is a number of these wells are disappearing into the colors in the background. That is because those wells are completely producing from the entire length of the well. The wells that you can see, if you look at the production in the background, you can see some black. And that means those are areas of low or no production. So what this tells us is that we could improve our completions in this particular play by using the information provided by this attribute of predicted production. You'd want to blank off certain zones where no production is expected, possibly drill in different directions, probably drill in different areas, and increase the NPV of this play by substantial amounts. In order to do this, we use a tool that we created called near wellbore volumes. These are volumes around the wellbore that extend some distance away from the wellbore. Why is this necessary? Because in today's world of unconventional plays, the production is not just related to what's immediately around the wellbore, but has an impact from some area around the wellbore. Some people may have heard of stimulated reservoir volumes. This is essentially the area around the wellbore that's producing. The near wellbore volume tries to capture that concept, and into this near wellbore volume, we can put anything from a 3D, be it seismic or the geomodel, and then we work through the various attributes to find which attributes are key to predicting whatever it is we're predicting, which in this case is production, but it could have been pressure, it could have been completion results, or any number of other things that are in the engineer's spreadsheet. Geomodeling AI is our package for geologists. We're going to look at some of the most detailed parts of it, but it has all the basic geological interpretation that you require. On the left, we're looking at a turbidite valley system in 3D. In order to do this, you simply have to sketch out where you believe that turbidite valley is, and then using parameterization to describe the channels within it, including the depth and width of those channels, how much they meander, whether they have levees, spill points, and lobes. You can quickly create a 3D complex turbidite valley system, which would allow you to understand what's going on in your turbidite valley system very quickly. And this can also be incorporated into your static reservoir model. On the right, we're looking at a point bar system. The point bar system, you simply have to define the final abandoned channel, which you're seeing here, and the location of the initial channel. Then you can incorporate templates, which we're looking at here, to describe the point bars. These templates simply fill in the space between the meanders, and then you incorporate the properties from your earlier interpretation of the facies and the facies properties into the facies that are in these point bar systems. And the same thing can be done for the properties within the channels, levees, and so forth of the turbidite system.
To conclude, Subsurface AI is all-in-one integrated platform, increasing productivity by 10 times to 100 times.